not know it, but the study of geodesy probably impacts your everyday life. Now I know what you're thinking. What is geodesy? Geodesy is a field of science concerned with measuring three properties of Earth: its shape, its orientation in space, and its gravity field. These properties change over time, so it's important that scientists are keeping tabs on Earth's overall position, as well as the position of its major parts, such as continents, oceans, ice sheets, volcanoes, and more. High-precision GPS instruments can record millimeter-scale movements, even over long time frames, which enables scientists to detect seemingly small changes to Earth's major features. Small changes with potentially hazardous consequences. So now that we understand how we obtain this data using geodesy, let's take a look at how we apply these tools in everyday life. The accumulation of magma in the shallow chamber below volcanoes causes the Earth's surface to actually inflate, deflate, and deform with changes in volume. By monitoring ground deformation in active volcanic zones, we can begin to understand the complex plumbing that lies below volcanic features, and hopefully forecast volcanic eruptions. Believe it or not, the Earth's surface also moves up and down during periods of drought. When water is present at or below the surface, the weight pushes the ground downwards, but when this water disappears, the surface begins to rebound. Entire mountain ranges like the Sierra Nevada grow and shrink by several millimeters just from changes in water. High-precision GPS and remote sensing can be used to monitor these small changes and in turn monitor drought progression and recovery. Geodesy is also used to monitor polar ice. Scientists use a variety of tools, including GPS and LiDAR, which stands for light detection and ranging. LiDAR is a remote sensing technique that uses a pulsed laser to measure distances between the laser source and the Earth's surface. By isolating various data points, we can generate precise 3D models with a range of applications. In this case, we can monitor changes in glacier speeds, depth, and extent. Satellite measurements can be used in a number of ways to better understand and respond to devastating earthquakes across the globe. For example, geodesy can be used to quantify ground surface ruptures and identify rockfall hazards. Additionally, remote sensing can be used to detect communities that suffered the greatest damage and deliver aid resources by priority. Geodesy can also aid in the response to man-made disasters like oil spills. Using remote sensing technology, we can detect oil spills in real time, hopefully preventing some serious ecological damage. GPS data allow optical remote sensing information to be linked with geospatial data, so scientists know exactly where an oil spill has occurred and how best to clean it up. Satellites and remote sensing also have uses in agriculture and forestry. Using this technology, scientists can analyze vegetated areas to assess the overall health of the plants and the soil. We can observe the visible and near-infrared wavelengths reflected by plants to determine the chlorophyll content. In addition, a specialized NASA satellite has been deployed that can measure soil moisture from space. These data produce global soil moisture maps that help us better understand the health of our world's fertile lands. GPS provides another essential service to society: timing. GPS satellites contain atomic clocks, which can relay super accurate time information to people who need it most. World financial markets, power grids, and hazard communication systems all rely on GPS data for precise timekeeping. GPS systems are key to safe navigation, and with the world of autonomous vehicles on the horizon, the precision and reliability of GPS nav systems is paramount. Personal vehicles and commercial fleets will rely on this information to determine their location and their position relative to other objects on the road. Last but not least, geodesy is also used to measure gravity. When the mass of an object increases, the gravitational attraction of that object increases as well. And because Earth's surface is not uniform, neither is its gravitational attraction. NASA has deployed 2 satellites that orbit the Earth in unison. In response to variations in Earth's gravity field, the distance between these 2 satellites will change, allowing scientists to measure Earth's gravity anomalies. These precise measurements of our planet's gravity are used to determine global sea level, an extremely important reference used in everything from construction to climatology.